Greetings to all. This is Maulika, Assistant Professor, Department of Physics. In this video, I am going to explain about the production of ultrasonic waves. First, what is ultrasonic waves? The sound waves of frequency greater than 20 kHz are called ultrasonic waves. These sound waves are not audible to the human ear. The term sonic applies to ultrasound waves of very high amplitude. Animals like dolphins and bats can hear these waves. We have four types of ultrasonic waves. One is shear waves, second one is longitudinal waves, the third one is surface waves, and last one is plate waves. We have tremendous applications of ultrasonic waves in daily life. This type of scientific concept is used in many different fields such as navigation, medicine, imaging, cleaning, mixing, communication, testing, and so on. We can produce the ultrasonic waves using piezoelectric generator. The principle of this generator is inverse piezoelectric effect. When an alternating potential is applied to one pair of opposite faces of crystals like quartz cut with their faces perpendicular to the optical axis, corresponding changes in the dimension of the other pair of the face of the crystal are produced. That is, alternatively mechanical contraction and expansions are produced. This is known as inverse piezoelectric effect or electrostriction. If the frequency of the oscillatory circuit becomes equal to the natural frequency of the crystal will be thrown into resonance and the ultrasonic waves are produced. The construction of this circuit diagram is it consists of primary and secondary circuits. The coil L1 and L2 of the primary are connected to the base circuit and collector circuit respectively of a transistor. The capacitor C is used to vary the frequency of the oscillatory circuit. L1, L2 or inductance coil and CB is a common emitter connected to the transistor. And C is the variable capacitor. This power supply is provided to activate the circuit. The coil L2 is inductively coupled to the secondary circuit, which comprises of the coil L3 and two metal plates A and B. This is shown in the figure. The crystal is kept in between the plates A and B for the production of ultrasonics. How it is working? The battery is switched on and the transistor starts working. The collector current flows through the circuit. It passes through the coil L1 and L2 of the primary circuit. This current is transferred to the secondary circuit by the transformer action and is fed to the plates A and B. By the principle of inverse piezoelectric effect, the crystal starts vibrating along the mechanical axis. The frequency of the oscillatory circuit is adjusted by the capacitor, and when this frequency is equal to the natural frequency of the vibrating crystal, resonance occurs. Then ultrasonic waves are produced along both the ends of the crystal. The piezoelectric generator is more efficient than magnetostriction oscillator, and we can obtain more frequency ultrasonic waves using this method. The output of this oscillator is very high and it is not affected by temperature or humidity. These are the advantages of this method, but the cost of the piezoelectric crystals are very high and the cutting and shaping of the crystal is very complex and difficult.